Hello everyone, this is group number 17 from D16 AD batch. So our project is brain tumor segmentation. The name of our project is NeuroTumor AI. Brain tumors are a very serious medical condition where early and precise detection is vital for effective treatment. Predicting the stage of tumor remains complex. Our research focuses on developing a machine learning system capable of segmentation of different types of brain tumors based on MRI scans. The main problem is doctors take about 2 to 4 hours for segmentation of tumor, and our model will be doing it in only a couple of minutes. This is the literature survey that we have done for our project. This is the flowchart. The doctor will upload the MRI scan, and our model will, based on the MRI scan, it will give the mask of the tumor. And we have basically segmented the tumor into three parts: the non-enhancing tumor, which will be shown by blue color; the peritumoral edema, which will be shown by green color; and the enhancing tumor, which will be shown by yellow color. uh, Basically we have used the BRATS 2020 and BRATS 2021 dataset together for training our model. The BRATS 2020 datasets consists of 369 patients. BRATS 2021 dataset consists of 1251 patients, and for each patient it's a 3D MRI scan, and we have four types of MRI 3D images: the flare, T1, T1 contrast, and T2. For the further training process, we won't be using the T1 because as we can see, the tumor is extremely light in T1, and while training this will not lead to any increase in accuracy, and it will lead to reduction in efficiency of the GPU. uh, we could go with any of the image, but the drawback is, as it is a 3D image which is represented in 3D array, so every x, y, z point will only have one value. By using three highly contrast images, every x, y, and z point will have three values as we are stacking these three images. In the pre-processing part, we will be stacking the three MRI scans, and there is a mask for each patient which represents a tumor with exact position. The reason we are using a UNET algorithm is because UNET is the most efficient way for training on medical images. As we'll see in UNET architecture, UNET first we do something known as downsampling. In downsampling, we go on conclusions where we go on reducing the size of the image, and we increase the number of features that are being learned. Then we do something known as upsampling, where we go on increasing the size of the image, but we reduce the number of features that are being learned. Then we use skip connections to connect both of the results. Hence UNIT is extremely efficient for medical images. This is the contraction path, the downsampling path that I told about. This is the expansive path, that is the upsampling path that I told you about. The activation function being used is ReLU. Then for preparation of the datasets, we normalize the images to bring their value equally between 1 and 0 using min-max scaler. We stacked the images into one image volume. We cropped the image from 240, 240, 155 to 128, 128, 128 pixels. Then we filtered out users volumes if image has less than 1% of the tumor. Then we used a custom data generator instead of the already available data generators in Keras and TensorFlow, because Keras and TensorFlow can't take in a NumPy array, and we'll be using NumPy array to load our data into the model. Then this is basically training of the model. We trained our model for 150 epochs. So initially we had trained only on the BRATS 2020 dataset for 100 epochs. Our accuracy was 73%. Then we used both the 2020 2021 dataset with 100 epochs. The accuracy was 81%. Then we trained for 150 epochs using both the years datasets, and now currently our accuracy is 85%. As you can see, this is the 150 epochs training, and this is the training and validation loss and training and validation accuracy charts. Our mean IOU, as you can see, is 0.85. That means our accuracy is around 85%. So this is the testing image, testing label, and prediction on the test image. Testing image is the image that is on which we are checking the accuracy. Testing label is the actual shape of the tumor, and on the right side of it is the prediction that has been done by our model. These are other 4 predictions of tumor that we did. These are the references that we used for our project. Thank you.